Hello, today we are going to be looking at arithmetic and geometric sequences. Okay, an arithmetic sequence has a series of numbers that add the same amount each time to get the next term. Examples: 7, 9, 11, 13. This is an arithmetic sequence where 2 is being added to each term to get the next term. Can you guess what the next term will be? So we added 2 to 7 to get 9. We added 2 to 9 to get 11. We added 2 to 11 to get 13. So if we add 2 more, we will get 15. We can keep adding 2 to get several more terms, or we can write a formula that will help us get any term, like the 20th one, or the 500th, or the nth term, 7, 9, 11, 13. For this same example, we know that our first term is 7, so that's our starting point. From there, we know that we are adding 2 every single time. We can represent that like this: 7 plus 2 multiplied by n minus 1. A subscript n is our output, the number we get back out. N is the number of terms we want. We use n minus 1 because we don't want to add 2 for our very first term. We always subtract 1 from the term we are on, and that tells us just how many times we want to add 2. For example, if I wanted the third term in the sequence, I really only add 2 twice. So that's why I would do 3 minus 1. So if we work that out, we would get 7 plus 4 would give us 11, and that would be our third term in the series. Okay? Now, given the sequence 14, 17, 20, 23, what is the 12th term? First, we're going to have to write our formula, okay? Plug in the correct missing numbers from our given sequence in red on the function below. So, our starting point is 14, right? It's our original number. So, A1 is going to be the 14. And then we're going to add, what are we adding each time? 14 plus what gives us 17? 17 plus what gives us 20? 20 plus what gives us 23? We're adding 3. And our nth term, we're looking for our 12th term. So we're going to do 12 minus 1. Okay? We have 14 plus 3 times 12 minus 1 is going to give us 11. So a to the nth, actually a to the 12th, because we're doing to the 12th term, equals 14 plus 3 times 11. Okay? A subscript 12 equals 14 plus 33. 14 plus 33 is going to equal 47. So 47 would be my 12th term. If we added 3 12 times, we would be at 47. Alright, given this sequence, 5, 12, 19, 26, what is the 8th term? So, we're just going to write the exact same equation we did on the problem before. We're looking for the 8th term, so I'm going to put my 8 subscript. Okay? My starting point is 5. And then I'm going to what am I adding each time, right? We have to add what we're adding. So what am I adding? 5 plus what gives me 12? 12 plus what gives me 19? Adding 7 each time. And then I multiply by, our term is 8 minus 1. So 5 plus 7 times 7. 7 times 7 is 49. So 5 plus 49, a subscript 8 equals 54. And that would be my 8th term. Okay, what is the 15th term of the following arithmetic sequence if given the function below? So we're looking for the 15th term. So all we have to do is plug in 15. Okay, 15 minus 1 is going to give me 14. 14 times 4 gives me 56. So I have 107 plus 56. 7 plus 6 gives me 13. That'll be 6, and I'll have 163. So 163 would be my 15th term. Alright, now let's talk about a geometric sequence. A geometric sequence has a series of numbers that are getting multiplied by the same number each time to get the next term. So, for example, 3 times what gives me 6? 6 times what gives me 12? 12 times what gives me 24? We're multiplying by 2. So, you can predict what the next term will be just by always multiplying by 2. But just like in the previous problem, we don't want to continue having to do it that way. We can build ourselves a formula and plug in. Okay? So, for this exact same example, if we want to know, we know the first term is 3. We know we're multiplying by 2. If we wanted to find what the third term was, we would substitute 3 in for n. We would subtract. 2 squared would give us 4, and 3 times 4 would give us 12. Alright, another way you can look at is the number of terms. You can count which term the number is. So the first number of term is 3. 3 times 2 would give me 2. That gave me the second term. 3 times 2 squared. You see how right here this is the same as 2 squared, which is what I've got right here, which is going to give me 12. 2 times 2 times 2. Each time I'm raising what I'm multiplying it by to the next power. Alright, so if we try it, we see 2 times 3 gives us 6. 6 times 3 gives me 18. 18 times 3. If we're looking for the 7th term, so my original value was 2. So my first term's 2. My R, what am I multiplying by? I'm multiplying by 3, and I'm looking for the 7th term. So I'll do 7 minus 1 as my exponent. So 2 times 3 raised to the 6th power and give me just a second. That is 729. So 3 raised to the 6th power is 729. So then we'd still have to multiply it by 2. So I would get 1,458. Alright, so given this sequence, what is the 6th term? Oh, we've already done this one. Excuse me. And we are done for the day. Y'all have a great day, guys.